Is this reality fake? Last time, we saw the argument that we might be living in a simulation. But arguments aren't proof. Today, we hunt for the evidence. Are there actual clues hiding in plain sight? Welcome back, or if you're just joining us, welcome. This is part 2 of our deep look into simulation theory. Today, we're exploring the specific arguments and potential clues that lead proponents, scientists, philosophers, tech leaders, to suspect our universe might not be the base reality. Now, that word proof, let's manage that right away. We're not revealing some hidden, undeniable proof today. Instead, we're examining the interpretations and lines of reasoning that proponents find compelling. Think of them as pieces of a potential puzzle, not a finished picture. Understanding these points is key to grasping why this isn't just sci-fi fantasy for some very smart people. Ready to hear the evidence? So, if our reality was a sophisticated program, run perhaps on silicon rather than biology, relying on that key idea proponents call substrate independence. That's the concept, that consciousness, like software, isn't tied to one specific hardware. It doesn't need a biological brain. It could theoretically run on any sufficient complex system, like a powerful computer. It's a big assumption, but crucial to the idea of simulated minds. Would there be telltale signs? Would the code of the universe leave fingerprints? And why might advanced beings even run such simulations? Proponents suggest reasons like scientific research, historical study, or maybe even entertainment. But regardless of why, the question is how we might detect it. Proponents believe the clues might be hidden in everything from the fundamental laws of physics to the very nature of information, and even in our own accelerating technology. Thinking through these clues forces us to question everything we take for granted. Whether you're innovating in business or just fascinated by big ideas, these concepts stretch the mind. All right, let's start with the first major argument proponents raise. Imagine getting the keys to the universe. You've got settings, dials for the fundamental forces. What are the odds you'd accidentally tune them to just right for stars, planets, and life? Scientists have discovered that many fundamental constants of nature, things like the strength of gravity, the speed of light, the mass of particles, seem incredibly finely tuned. If these values were even slightly different, poof, no stable atoms, no stars, no galaxies, certainly no life as we know it. Imagine if gravity was just a tiny bit stronger. The universe might have collapsed back on itself instantly. Or a tiny bit weaker, and maybe galaxies never would have formed at all. Now, some say this is just luck. Maybe we won a cosmic lottery. Or perhaps there are countless other universes with different settings. The multiverse idea we might explore later. But simulation proponents ask, doesn't this incredible precision look a lot like design? Like someone carefully setting the parameters? Could these constants be parameters deliberately set by simulators to create a universe capable of eventually hosting observers like us? Complex beings who can look around and ask these very questions? So, clue number 1. The universe's delicate balance suggests potential design to proponents. But the arguments go deeper than just the settings. Proponents also look at the fundamental language the universe seems to speak. Now, moving on to the second line of reasoning. Why is our universe so breathtakingly mathematical? Is it a coincidence that equations on a blackboard can accurately predict the orbits of planets or the behavior of subatomic particles? Physics runs on math. Einstein's relativity, quantum mechanics, it's all expressed in precise mathematical language. It works incredibly well. Unreasonably well, some might say. This leads some thinkers, like physicist Max Tegmark, to take it a step further and suggest reality is fundamentally mathematical, not just described by math, but actually made of math in some sense. Then there's physicist John Wheeler's famous idea, it from bit. The concept that the physical stuff of the universe, the it, actually arises from information, the bit. Think of it like this. Maybe the most fundamental layer of reality isn't matter or energy, but information itself. like the zeros and ones that make up all the digital data. If reality is information, processed according to mathematical rules, well, what does that sound like? To proponents, it sounds remarkably like computer simulation. A system processing information according to a programmed set of mathematical laws. Clue 2. The mathematical and informational nature of reality. It aligns intriguingly with the idea of a universe that is fundamentally computational. Math is elegant, but physics gets weird at the smallest scales. Could quantum mechanics be dropping the biggest hints of all? Okay, the third area, and this one requires caution. Could quantum mechanics be dropping the biggest hints? First, quantum stuff comes in chunks. Discrete packets called quanta. Energy, charge, even possibly space and time themselves at the tiniest level aren't smooth and continuous. Proponents ask, is this like the universe having a pixel resolution? A fundamental limit to how smooth reality can be, just like pixels on a screen? Then there's the infamous observer effect. Very simply put, the act of measuring or observing a quantum system seems to change it, locking it into one definite state from a cloud of possibilities. The analogy drawn? Like a video game only rendering the fine details of an object or area when the player actually looks at it, something called lazy rendering, to save processing power. Maybe the universe only calculates the specifics when something observes, and maybe the speed of light is like the simulation's ultimate processing speed limit. Even spooky quantum entanglement, where particles seem linked instantly over vast distances, something very hard to simulate classically, makes proponents wonder if it reflects the simulation's underlying, perhaps non-local code. There's even a related idea called the self-simulation hypothesis, suggesting the universe might be a kind of mental simulation where consciousness itself plays a role in generating reality, linking quantum effects even more directly to the mind. But that's a complex idea for another time. Now, it's absolutely critical to understand mainstream physics has explanations for all these quantum effects within standard theory. Concepts like decoherence explain the observer effect without needing conscious observers or simulators. Quantization arises naturally from the math. These simulation links are analogies. They are interpretations favored by proponents, not established scientific facts or proof. Does it mean the standard physics is wrong? Absolutely not. We'll dig into the standard physics more in part 4. So keeping that crucial distinction between analogy and proof firmly in mind, let's summarize the proponent's view. Clue 3. The interpretation. Quantum phenomena offer analogies to computational systems, which proponents find suggestive. Even if physicists have other explanations, it's about the pattern they see. From the quantum realm back to our everyday world, the final argument might be the one staring us right in the face. And for the fourth and final main argument in this episode, let's bring it back home. Forget physics for a second. Think about the device you're listening on. Think about modern video games, virtual reality, artificial intelligence. Isn't our own progress the most compelling clue? Think about how far video games and virtual reality have come in just a few decades. From simple beeps and blocks and games like Pong, to virtual worlds today that can look and feel almost indistinguishable from physical reality. It's not just games. Look at science itself. Scientists now use incredibly complex computer simulations to model everything from climate change and galaxy formation to how proteins fold inside our bodies. The increasing power and accuracy of these simulations show just how good computation is getting at mimicking complex reality. The argument, pushed strongly by figures like Elon Musk, futurist Ray Kurzweil, computer scientists Rizwan Virk, and others in the tech world, is simple extrapolation. If we are rapidly approaching the ability to create simulations that feel real, isn't it almost certain that civilization millions or billions of years ahead of us already cracked it? And if they could create these simulations, wouldn't they likely run lots of them for research, for history, or who knows for what other reason. Clue 4. Our own technological trajectory, including powerful scientific simulations. It suggests creating universe simulations is plausible, making it likely someone somewhere is already doing it. So let's recap the case for simulation. A universe seemingly fine-tuned for existence, laws written in the language of math and information, quantum behaviors with intriguing computational parallels, and our own technology racing towards creating virtual worlds. Individually, each clue has counter-arguments, which we'll definitely get into in the next episode, but proponents argue that taken together, they paint a consistent picture, a reality that behaves remarkably like you might expect an artificial computer system to behave. Before we move on, I'm curious, which of these arguments resonates most with you? The fine-tuning, the math, the quantum stuff, or our own tech progress? Let me know in the comments below. So, is this the proof reality isn't real? No, but hopefully you now understand why simulation theory is more than just a wild guess. It's supported by specific lines of reasoning, interpretations of physics, observations about the universe, and logical extrapolations from technology that lead proponents to find it genuinely plausible. Want to unlock the power of AI? Our free newsletter gives you the tips, trends, AI news, and tools you need to succeed. Sign up with the link in the description below. Your journey doesn't stop here. Watch our next video right here, and keep building your knowledge.